Hi, Mr. Ko. My name is Kai Xuen, and my trade number is AF170243. First, I will present about our project summary. So, it is the double-story residential house at Kluang, Johor, and the construction cost is approximately 500,000 ringgit, Malaysia, and is approximately 200 square feet, and it is fully reinforced concrete buildings, and the building is subjected to vertical load only. And the relevant standard codes and guidelines used in this project are Eurocode 1s and Eurocode 2s. And design exceptions, we use the ultimate limit states, which is 1.35 permanent loads and 1.5 factors variables of variable loads. Next, material properties, loading, application, and distributions of our projects. So the statement of the projects. Type of wall we are using brick walls, and the dead load on slabs is 1 kilonewtons per meter square. Variable load on slab is 1.5 kilonewtons per meter square, and the dead load on roof is 1.0 kilonewtons per meter square, and variable load on roof is 0.5 kilonewtons per meter square. And our ceiling heights, first floor to ceiling height is 3 meters, and also ground floor to first floor height is 3 meters. And the material we use, concrete grade is M30s. The steel grade is S500s. Our concrete strength is 25 newtons per millimeter square, and our characteristic strength of concrete is 20 newtons per millimeter square, and our characteristic strength of steel is 416 newtons per millimeter square, and our unit weight of concrete is 25 newtons per meter square, and our weight of brick is 2.6 kilonewtons per millimeter square. The beam I choose is 5 per C2E, which is shown in these figures. Firstly, the specifications as the same as I present in previous. Okay, I assume the diameter of bar 1 is 16 millimeters, the diameter of bar 2 is 10 millimeters, and the diameter of length is 6 mm. And the beam size is 225 by 500 mm. So next, loading and analysis. As shown, the slabs is two-way slabs, and we calculate the permanent loads and variable loads that they're distributed from the slabs. That's the calculation here, and therefore we calculate out the design actions, and then we manipulate out the shear force and the bending moment. Next, for the main reinforcement, we calculate out the K factors is less than the K balance, so the compression reinforcement is not required. But due to safety, we insert a smaller diameter rebar to compression reinforcement. So we decided to use the rebar with two rebar with diameter of 60 meters for the tension reinforcement, and the rebar with 10 mm to the compression members. For the shear reinforcement, after calculating out the spacings as maximum spacing, we decided to use the 6 mm diameters rebar with 125 millimeters spacings. Since the shear reinforcement, since our design shear force is much lesser than the shear resistance of minimum links, hence we just apply the same diameter of rebar as a links and spacings to the whole beam, which is 6 diameter rebar with 125 spacings. Next, for the deflection checkings, the L per D actual is less than L per D allowable, so the deflection checking is okay. And for the cracking, the bar spacing is less than the maximum allowable bar spacing, so it's also okay. So next, these are the detailings of this beam. As we can see, there's for the tensions is 2H16s, and for the compression reinforcement is 2H10s, and for the links is 6 diameters rebars with 125, and there's the 33 number of links. That's for me. Thank you.
Okay, for Esteem project, I choose to design beam D34, which is this beam. Okay, For the specification, as shown, this is the specification of this beam. And then this beam size 125 times 500 mm. Okay, then we go to loading and analysis. For this beam, we got two floor slab, which is floor slab 7 and floor slab 6. For this floor slab, we got two way slab. And then we determine the BVX value, which is for floor slab 7, we got 0.48. And then for floor slab 6, the BVX value, which is 0.34. And then we calculate the WGK, which is 1.71. And then for WQK, 2.56. And then for action on beam, which is self-weight beam, we got 1.09 kilonewton per meter. For total GK, 2.8 and QK, 2.56 kilonewton per meter. For design action, we get 7.62 kilonewton per meter. And then this is shear force and bending moment diagram. For shear force, we get 13.72 kilonewton, and for bending moment, we get 12.34 kilonewton meter. Okay, next, we go to main reinforcement. For main reinforcement, effective depth, which is D, we get 451 mm, and D prime 37 mm. Design bending moment, which is MED, 12.34, and then we calculate K value. For our K value, we get 0.024, and for K-bar, 0.167, which is K is less than K-bar. So, compression reinforcement is not required. We calculate D, we get 0.82D, and then for area of tension steel, which is AS, we get 83.38 mm square. For minimum and maximum reinforcement area, AS mean, we get 73.29 mm square. And then we use this. Okay, next, for shear reinforcement, where shear design force, which is VED, 13.72 kilonewton, and then we calculate this shear characteristic, and then we use this value, and for shearing, we calculate, and then we get 0.034 for this is our trailing and minimum links, and then we use H6125. Okay, next, for deflection, for percentage of required tension reinforcement, which is rho, we get 0.0014, and for reference reinforcement ratio, we get 0.0045. So that rho value is less than rho naught. So for the structural system factor, we use 1.0. Okay, this is calculation, we get 104.07. Okay, next, for this is show the modification and calculate cracking calculation. For the cracking FS, which is we get 38.85 Newton per millimeter square. Max allowable bar spacing, which is 300 mm. Bar spacing we get 57 mm, which is less than 300 mm. So okay, this is also okay. And then I will show the detailing. And this is the detailing of beam D34. That's all. Thank you.
Okay, my name is Chong Yee Hau and my machine number is AF170246. For my part of manual calculations, I choose the beam from D1/2, which is this one. So this is a simple supporter French beam. So now I will explain about the process. So first of all, we know that we will decide the slab thickness and the unit weight and the weight of brick wall. After that, we find the characteristic actions, which is QK and GK. Since this is a simply supporter French beam, we will find the B effective for the beam and also find for the FF. So by finding the effective French wedge, we know that for for this beam, the B effective is 1281. So we will base on this value and find the loadings and others. After that, we will find the loadings. We will find the load or slab. We will find the GK and QK. For the GK will be the 4.75 and the QK will be 1.5. After we finding the GK and QK, since this is the French beam, then there will be two slabs. One slab beside the left hand side and another slab will be the right hand side. So based on the slab, we will find the characteristic of permanent load and also finding the characteristic of variable load. So finally, we will analyze the shear force and bending moment. We will find the main reinforcement and find the shear reinforcement. And last, we will compare the detailings. We will ensure that the cracking process will be passed and okay. So this is my detailings. Okay. So for the verifications, we carry out the manual calculations of beam analysis at beam D slot 1-2, which is from the ground floor. The result we obtain from the Esteem software will not as the table below, which is we can find for the shear, we can get the percentage of difference is 6.45, and for the bending moment, there will be 13.39. So based on the table, the percentage of difference between the manual calculations and the Esteem computed of bending moment value is 13.39, which is considered a high difference or percentage in test. So while the percentage of different value between the manual calculation and the Esteem computed of shear reinforced force is 6.43, which is considered less difference, but cannot be neglected for the design value. Okay, such differences occur may due to several factors. One of the factors is because of the decimal or round off for our manual calculations that will affect the difference between the manual calculation and software calculations. The round off will provide the larger value of the loading distributions as it will contribute to the biggest shear values. While in Esteem, all the calculation is done by the system and the value is generated by all by the digital data, including the finite digit of the decimal places we consider in the system, which will evaluate the exact value of the non-rounded off or chopping off of the mathematical approximation in numerical error. So this is our 3D building model computed by the Esteem. So in conclusion, the Esteem software is useful tool for combining both design and analysis and of the reinforced concrete structure into a seamless and efficient single model based process. The software is proven to be useful in the construction industry in the country as large and small scale project that benefited from its use throughout the years. So this provides a project stakeholder insight into determining the type and the duration of the work that is required, and also the number of material is needed. So the design and the analysis of double-story residential of the houses is successfully completed using the Esteem software. So the design following the standard code and the guideline used in Malaysia for reinforced concrete building, which consists of Eurocode 1 and 2. So the manual calculation for each type of the structural member based on the Eurocode standard and also be done to be compared with the result from the Esteem. So that's all. Thank you.